Hello, welcome back to Advanced Analysis of Single Subject Design. This is video part 4, and we're going to resume with steady state strategy and baseline logic. Baseline logic entails 3 elements: prediction, verification, and replication, each of which depends on an overall experimental approach called steady state strategy. That's from Cooper Heron and here in 2007. Now, steady state strategy entails repeatedly exposing a subject to a given condition while trying to eliminate or control any extraneous influences on the behavior, and obtaining a stable pattern of responding before introducing the next condition. So, thus far we've talked about independent variables, dependent variables, and extraneous variables. And when we're using single subject design to evaluate a treatment or intervention or practice, or to conduct an experiment, answer a research question, we're looking to demonstrate a functional relation between an independent variable and a dependent variable. In order to do so, we have to try to eliminate or control extraneous variables. That's what's meant by extraneous influences on behavior. In the steady state strategy, what you want to do is you repeatedly collect data on the dependent variable, and you manipulate aspects of the environment to control or remove extraneous variables until the data path in your graph, which represents the dependent variable, is steady, that is, with low variability. Variability in the data path of a graph is the extent to which the data points diverge from a trend line. Okay, so the extent to which the data points are bouncing all over the phase or the condition. Alright, so if you have a lot of variability in the data path, the problem with that is it's difficult to make good predictions and to verify those predictions and then to replicate changes in the dependent variable that previously were predicted and verified. That is, in order to demonstrate a functional relation between behavior and environment, in most types of single subject experimental designs, you need a steady, stable pattern of responding in one condition before introducing the independent variable or making a change in the independent variable in the next condition. Condition changes are based on this steady state strategy, relying on level, stability, and trend. Okay, so let's talk about all of these in the context of these data. Now, this was a study in which myself and my colleague were interested in how we could address the food selectivity of a boy with autism by differentially reinforcing variability in the foods he consumed within a session. During the lag 0 condition, during the session, the boy could eat any one of 5 different foods presented to him, and for each bite he consumed, he received 30 seconds of access to a high preferred toy or activity. In the lag 1 condition, this is a lag 1 schedule of reinforcement, we only delivered high preferred item or activity during the session for each bite that in the session that was different from the last bite in the session. For example, if on one trial during the session he took a bite of a pretzel, in the next trial during that session he had to take a bite of a food that was different from the pretzel, let's say popcorn or peanut, in order to get access to the high preferred items or activities. And And I want to draw your attention to the top panel here. The x-axis is sessions, but the y-axis is the percentage of trials with independent variant consumption. It's the percentage of trials where he ate a food that was different from the last food eaten within the session. Ranges from 0 to 100%. And in this first lag 0 condition, where it didn't matter which food he ate to access the preferred item or activity or the reinforcer, what we observed was a gradual decrease in variant consumption. In other words, the foods consumed during the sessions became more repetitive. All right. So notice that this is a pretty flat line. It's decreasing, right? But it's flat. There aren't data points bouncing all around this trend line here. This is a decreasing but stable pattern of responding. This stable pattern of responding enabled us to make a prediction. I could predict that at this point, if I do not introduce the lag 1 schedule and I continue to reinforce any bytes consumed, that the percentage of variant consumption, let's say in a 5th session, because there were 4 sessions that we had data for in lag 0, if we collected data in a 5th session, we would expect the data point to be between 0 and 20, right? And then the 6th session to be between 0 and 20, probably between 0 and 10, and so forth. So we would expect a continuation of the decrease in variant consumption if we don't change anything in the environment. We hold all the variables constant. But I was interested in examining whether this lag 1 schedule of reinforcement could increase variability in consumption. So we introduced this phase change line. That's what this solid vertical line is, a phase change line. Then we introduced the lag 1. And overall, in the beginning of the phase, variant responding started to increase, as would be expected or predicted by the lag 1, but more specifically, this suggested that perhaps the lag 1 schedule of reinforcement can increase variant consumption. But one thing I want to note about this data path in this phase is that it's highly variable, right? So there's a lot of variability here. It's not like the data points fall along a straight line. Right? So this variability makes it difficult to predict in the next condition what will happen if we remove the lag 1 schedule. That is, if we no longer require the participant to vary his food consumption to produce or get access to the preferred items or activities. In the next phase, would it decrease or increase? Well, it's hard to tell, but if the decrease were dramatic enough, then we might be able to detect a change between conditions. All right. So now let's take it back to lag 0. Now lag 0 data path enabled us to predict that if we continue to collect data under a lag 0 condition, then variant responding would continue to be low. It would be, proceed to lower values. So that enabled us to make a prediction here in this lag 0. In other words, we would expect, based on the data path in the first lag 0 condition, that if we return to a lag 0 condition, we would observe low variant consumption. And that's exactly what we observed, right? So you see that there was a decrease in variant consumption across 5 sessions within this lag 0 condition. That verified the prediction made by the data path in the first lag 0 condition. Okay, it also replicated the overall low responding observed in the last session of the lag 0 condition. Now, this data path enables us to make a prediction. Right? So this data path predicts that if we weren't to change anything and we were to continue to collect data, then variant consumption would continue to be low. And the lag 1 data path allows us to predict that if we were to reintroduce the lag 1 schedule, we can expect that variant consumption will increase somewhere between about 0% to about 80%. All right, and so when we reintroduced the lag 1 schedule of reinforcement, where variant consumption was required to produce the preferred item or activity, we saw an immediate increase in variant consumption that gradually increased across the phase. Now, this data path replicated the increase in variant consumption observed in the first lag 1 condition. Okay, there's replication. It also verified the prediction made by this data path that the initial sessions would fall somewhere between 20 and 80%. Right? So I've described baseline logic, prediction, verification, and replication in the context of this design. I've also shown how steady state strategy was used to obtain stable pattern of responding in this data path and this one, and I also used that concept to explain how prediction was complicated by a lack of stability in this data path in this first lag 1 phase. Okay, we're going to talk more about level stability and trend going forward, but this is just a refresher for those of you for whom this is familiar, and it's also just a brief introduction for those of you that have not seen this before. So I can conclude by saying that, hey, there was a decrease in variant consumption in the lag 0 condition. There was a change in trend in variant consumption in the beginning of the lag 1 condition, but overall there was no trend in the lag 1 condition. There was no change in the level, which is about the average value of the data points relative to the average value of the data points in the first lag 0 condition. But variant consumption was low in the second lag 0 condition and high as expected in the second lag 1 condition. These data suggest a functional relation between variant consumption in the lag 1 schedule of reinforcement, specifically that the lag 1 schedule of reinforcement increased variant consumption of foods within sessions by a boy with autism and food selectivity. ASR 11. Prediction, verification, and replication are elements of A, baseline logic, B, steady state strategy, or C, visual analysis. A couple more seconds. Okay, I'll close the poll, and the answer here is A, baseline logic. ASR 12. A steady state strategy focuses on A, the level, trend, and stability of the data path, B, baseline logic, or C, prediction, verification, replication. A couple more seconds. Okay, I'll close the poll, and the answer is A, level, trend, and stability of the data path. Alright, that concludes this video part. In the next video part, we'll talk about baseline, level, trend, and variability.